Welcome back. Today's lesson is about analyzing scatter plots and determining the line of best fit. When we look at scatter plots like the one shown, a scatter plot shows dots of random sorts that connect both the independent and the dependent variables. So if you remember from previous lessons, when we're talking about independent, we're talking about data that goes across on the x-axis, and the dependent variable is going across the y-axis. And we want to see, is there a connection with the dots that are placed on a coordinate grid if those coordinate pairs are related to each other with the independent and dependent variable? Is there some kind of a connection? So when we're talking about the line of best fit, we want to see, can we draw a line that represents the average set of data? Basically drawing a line through the data points that are given. It won't touch all of the points. Some will be on the line, some will be above, some will be below, but that line represents the average data given the set that we have. So let's go ahead and see if we can draw a line through this. I'm going to go ahead and choose that color. And it looks like that our dots, our data set, is randomly scattered, but it looks like it's kind of going in a general direction. So if we were to take a line and draw it through the general data, I would say probably maybe about like that or so. Then we see we have some data that's down here below. We have some that's down here below. And we have some that's above. But basically, this line represents the data as a whole. So that is called our line of best fit. Go ahead, pause the video, copy all of this information, the graph, the line, and the definition into your notebook. Okay, now that we've looked at the line of best fit, we're going to see what kind of analysis we can make given that line. So data can be analyzed to determine, again, the relationship between the independent and the dependent variable. Oftentimes we call this a correlation. So is there a correlation between the two sets of data? Well, there are three types of correlations that we can have. We can have a positive correlation, a negative correlation, or actually no correlation, where the data doesn't seem to go together at all. In the first graph, it's a positive correlation, and this is measuring the temperature and money. So it's saying as the temperature increases, the money that is collected or made or whatever is also increasing. And we can tell that because of this blue line right through the center of this data that is showing that the line is going up. As temperature increases, as the temperature parts go up, so do the value points in dollars, okay? So as X increases, Y also will increase. That's a positive increase, it's going up. A negative correlation is represented in this graph, and the line is, you can see, starting at the top and it's going down. So we always read our graphs from left to right, and at the left it's starting high and it's going down. So as the hours of exercise per week increase, the resting heart rate decreases. So this has a negative correlation. Negative doesn't necessarily mean a bad thing. In this case, the more you exercise in a week, your heart rate goes down, your resting heart rate goes down, and actually that's a good thing. That's a healthy situation. So a negative correlation, again, is when the line goes down from left to right. As X increases, as our independent variable increases, our Y decreases, our dependent variable decreases. And then finally, we have no correlation. And that means that all of the dots are randomly scattered throughout our grid, but we can't really represent a line that shows anything. I mean, even if we tried to draw a line going through the center right here, it really doesn't represent our data. Nothing's really changing. So we would just say that this, in fact, would be a no correlation situation. Okay, so when there's no real cluster of data, no patterns identified, there's no correlation between that. I'd like you to go ahead, pause, and copy this information, the 3 types of graphs, what they mean, and everything into your notebook. All right, well, let's go ahead and look at some examples and see what we can determine. So this is a scatter plot of ice cream consumption against temperature. So let's see what's happening to our independent variable says it's temperature. So we can see temperature is increasing, and as temperature increases, then what happens to our dependent variable? Our dependent variable is the consumption of ice cream. And as we see, our data kind of looks clustered together, and it's generally going in an upward direction. So we can say that we could draw a line representing our data kind of going like this. I would say maybe more like that. Okay? And it's saying as the temperature increases, as we go up in temperature, then the amount of ice cream that we consume, the amount of ice cream that we take in, increases as well. So that's a positive correlation or a positive relationship. In this next example, we are trying to see, again, looking at our scatter plot. Here are all the parts that have been randomly placed based off of the data. And this is the regression of standardized predicted value. So as the price of something changes, what happens to the residual value? Well, as you can see, we can't really cluster it together. It's just kind of randomly scattered all over, and we can't draw a line. If I go up, that doesn't seem to represent the line. If I go down, that doesn't seem to represent it. In fact, what we have is a giant X, and in that case, we would say, what kind of a relationship does it have? And it has no relationship. So we're going to go ahead and say that that has no relationship. Again, there doesn't seem to be any strong connection between our X and our Y data. All right. All right, well, tonight for the Your Turn page, what I'd like for you to do is write down numbers 8 through 15 in your notebook, and I want you to tell me whether or not each situation represents a positive, a negative, or no correlation. So you're going to have to think a little bit about what would happen as your independent variable increases. What happens to your dependent variable? Does it increase? Does it decrease? Or really they have nothing to do with each other? Again, if they increase, if your outcome increases just like your input increases, then it's positive. If your output, which is your Y value, decreases while your input or your independent variable increases, that's negative. And if there's just no relationship whatsoever, then that's called no correlation. So answer these questions tonight, and I'll see you next time.